Shown on screen is the mechanism of a complicated enzyme-catalyzed reaction in the forward direction. This assessment asks us to show the mechanism of the reverse reaction. Despite it being a complicated mechanism, the principle of microscopic reversibility says that if what's shown is the fastest way forward, the reverse of those arrows will be the fastest way back. And so all we have to do are provide arrows that reverse each of those steps. And so we can do that by showing this nitrogen grabbing a proton to push these electrons onto oxygen. That matches the acid-base reaction that happened in the forward direction. We can also provide arrows that show this negatively charged oxygen attacking this carbon here. We'll note that that carbon-oxygen bond was the one that broke in the forward direction. At the same time, these electrons in this CO bond will go up to grab a proton here to protonate that oxygen, returning these electrons in the nitrogen-hydrogen bond onto nitrogen. You'll note that each of the arrows that we've drawn in this reaction are the reverse of arrows shown here. Again, the principle of microscopic reversibility.